For many people, the Pythagorean theorem will be reviewed. Of course, this is something invented by a Greek guy a long time ago, but it still works today. The Pythagorean theorem is basically just a tool that we're going to use to solve right angle triangles, which you can see to the right here. And the theory is actually quite simple. It's just a formula, and it's a squared plus b squared equals c squared. And if we were to label this triangle that way, we could label this A and B, and this C. Now you'll see that it actually isn't important whether I labeled this side A or B, or this one A or B. It could have been either one. But it's absolutely essential that I label this one C, because in this formula, the C is the longest side. And that longest side, you may know, we call the hypotenuse. So let's get through this quite quickly. If we want to solve a right triangle like this, it's just a matter of plugging some numbers into a formula. So let's look at the possibilities here. Okay, so let's say you've got a side that is 7 meters, say 7 centimeters. This one is 4 centimeters. How long is this one? We'll call it C. Gotta make sure this is a right triangle, and a right triangle should always be labeled with this little box here, and that box means, of course, it's a 90-degree angle. So let's plug these numbers in. Now, it's not actually important whether I put 7 in for A or for B, as long as I'm making sure that I'm not putting it in for C. So let's say 7 squared plus 4 squared equals C squared. And I'll solve 7 squared and 4 squared. And I'll combine those to 65 equals C squared. Now, if you recall anything about exponents, the opposite of squaring something is the square root of something. So to get rid of that square, we do a square root. The square root of C squared is just C, and the square root of 65 would be just over 8, I believe. 65, 8.06. Okay. So, looking at around 8.06 centimeters. And that's how long that side is. So we can relabel this 8.06 centimeters. So it's really just as simple as plugging some numbers into an equation. Now I just want to try one or two more because sometimes it can be slightly more complicated than this. Okay, so we're going to keep the same triangle, but we're going to change some of the measurements. So let's say we know the long side, and it is 125 kilometers, and this here would be, let's say, 60 kilometers. How long is this side? And we'll call this side X. Now, the important thing to remember here in terms of A, B, C, and X and all these letters is that it doesn't really matter what you name them as long as you remember that the side that's on its own in the equation is the longest side. Okay, so let's plug these in. We're going to turn A squared into X squared plus 60 squared equals 125 squared. So notice I've taken that longest side, the hypotenuse, and I've plugged that in where C would be. Alright, so we've subbed everything in here, and we notice that X squared is over here on the left along with the 60 squared. And so we're going to have to isolate that variable. So since 60 squared is being added, we're just going to do the opposite operation, and that should get rid of it for us. Right, so we can write it this way. I'm going to cheat a little bit here. Skip the step. So we're going to end up with X squared equals, because notice these 60 squareds cancel out, 125 squared minus 60 squared. Now I can't do that in my head. I don't know about you. So let's figure this out. 125 times 125, 15,625. And 60 squared is 3,600. And that should give us 12,025 and now we're just missing that square root. And so we're going to end up with x equals the square root of that big number. Again, if you can do that in your head, I don't think you need to be watching this video. 109.7 or so. Okay. So 109.7 kilometers. You don't forget your units. And of course, we could go over here and we could write that in. 109.7 kilometers. And that's it for Pythagorean.